So we have our instantaneous slope formula that we've been looking at. We have the limit as x approaches c of f of x minus f of c over x minus c. And this represents a fixed point, cf of c, whatever our function is. That's our output when we plug in c. We have our fixed point, and then we have this point, xf of x, that's going to get really close to the other point, cf of c. And so as we let x approach c, this average rate of change is going to start to become an instantaneous rate of change at x equals c. So the extension now is to talk about the limit definition of a derivative. So we talked about how we have the limit as h approaches 0 of f of x plus h minus f of x over h. So the difference is now we have a function here. Before we had like a normal output. So what this is going to do is this is going to spit out a function that will allow us to find the instantaneous slope at any given point. But we want to understand each piece of this. So if we look at this picture, here we can think of the black point as being f of x, and the red point as being f of x plus h. So the difference in our x values is h, and then we have our difference in y, which is f of x plus h minus f of x. So this is an average rate of change. But as we let h approach 0, this red point is going to get closer and closer and closer to this black point, and then that red secant line is going to start to be this blue tangent line. And this will work for any function at any x value we want. So it's helpful to look at a couple examples. First up, we have f of x equals x squared, and we're trying to find f prime x, the derivative of f of x. So we say f prime x is what we're looking for. So we can find f prime by just simplifying this, and hopefully what we want to do is plug in h equals 0 at some point so we can find our final derivative, but right now we can't plug in 0 because we'd get x squared minus x squared over 0, which is 0 over 0. So what we do is we FOIL out x plus h squared, we multiply that out, so we get x squared plus 2xh plus h squared minus x squared, all divided by h. And then we can combine like terms. We have an x squared, we have a negative x squared. And then we can, there's a couple different ways you can think about this. You can either just factor out an h and get 2x plus h on top, and then you have your h on bottom, and those will cancel. Some people prefer to not actually show that step of factoring out, and they just say, well, this has an h and this has an h squared, so we're going to cancel that h and we're going to cancel one of these h's, and we're just going to get left with 2x plus h. But don't forget, the limit as h approaches 0 is what we're doing here. We're letting that difference in our x values disappear. So now that we've canceled the h on top and bottom, we can just plug that right in, and we get that f prime x is equal to 2x. So what that actually tells us is it tells us the slope of 2x, or sorry, the slope of x squared at any x value we want. So x squared at x equals 4 has a slope of 8. X squared at x equals 5 has a slope of 10. And we can do that for any x value. It will tell us exactly how quickly x squared is either increasing or decreasing at any x value. Another example, f of x equals square root 2x plus 1. So again, we're going to apply our limit definition. We replace x with x plus h. Note the parentheses, very important. F of x plus h means instead of writing an x, we're going to replace that with x plus h. So we have square root of 2 times x plus h plus 1 minus f of x, all divided by h. So same thing as before, we're going to multiply by the conjugate here, and that's going to take us, that's going to allow us to eventually cancel our h. Pause the video if you need to catch up, but I just multiplied by the conjugate, which canceled my square root signs. And then here's my conjugate now. We did it on top and on bottom. So now we need to combine like terms in our numerator. So we're going to end up with a 2x plus 2h up there, right? And then this is going to be, and so plus 1, and then minus 2x minus 1. We distribute that negative, and then what we can recognize is the 2x is going to cancel with the negative 2x. The plus 1 is going to cancel with the negative 1, which is going to leave us with just 2h on top. So again, pause if you need to catch up, but we have 2h on top and an h on bottom, so these cancel. And now that we've canceled those h's, we can't forget we were taking a limit as h approaches 0 from the beginning, so now we can replace that h with a 0. So what does that give us? We have 2 on top. We have root 2x plus 1 plus root 2x plus 1. Okay, well, if we add those, there's 2 of them, so we have 2 over times 2 root x plus 2x plus 1. Okay, and then those 2's cancel. So our final f prime for this function, f prime x, equals 1 divided by root 2x plus 1. So if f of x is equal to root 2x plus 1, the derivative of that we just showed is 1 over 2 root x plus 1. And now we can plug in any x value we want here and it will tell us the slope. So then the other thing we talked about is we just looked at some different quadratics, x squared, 3x squared, 5x squared. We applied the limit definition and simplified and found out that derivatives were 2x, 6x, and 10x respectively. So then people started thinking, well, it looks like we're multiplying the coefficient by 2, right? So we get 2x, 6x, 10x, and then it was x squared, and now it's x to the first. It's x to the first. It's x to the first. So we came up with a guess for what f prime x might be for x cubed. Some people thought it might be follow a similar idea and get 3x squared. And we want to see if we can prove that that's what the derivative is using the limit definition. The issue here is we have x plus h cubed, which is a little bit, it's kind of annoying to multiply out. It's not equal to x cubed plus h cubed. That's what some people think that it multiplies out to, but that's not quite right. And how we should think about it is x plus h cubed is x plus h times x plus h times x plus h. And we've already worked with some quadratics where we had to do x plus h times x plus h. We got x squared plus 2xh plus h squared. And this is 2. X squared plus 2xh plus h squared. And we're still multiplying that now by x plus h. So it's definitely not going to be x cubed plus h cubed. We did a lot of work in class to show what it is. I'm just going to write it here. But you just have to basically you have to make sure you multiply each piece by x, and then write those terms, and then multiply each piece by h and write those terms, and then you combine like terms. We use the box method in class. Review that, again, review the day 3 PowerPoint if you want to see the full work for multiplying this out, but I'm just going to write it now. So boom, there it is, x cubed plus x squared h plus xh squared plus h cubed minus x cubed. So it looks kind of annoying right now, but the nice thing is a lot of stuff's going to start canceling. X cubed and negative x cubed are gone. And then we notice that each piece remaining has an h, so we can cancel this h. We can cancel one of those h's and make that h to the first, and we can cancel one of those h's and make that h squared, and now this one's gone. So we get x squared plus xh. Sorry, I just caught myself really quick. I made a mistake here. This needs to be 3x squared, and this needs to be 3xh. That's very important. So this is still 3x squared, and this is 3xh. Okay, and then plus h squared. So that's what we have right now. Again, the only difference is that I just messed up these coefficients, so make sure you put a 3 in front of there, and that's going to be important for our final derivative. So now that we've canceled our h's, and we're taking a limit as h approaches 0, we're going to plug in 0 for that h, and for that h, which is going to take out those whole terms because we're multiplying by 0. So we get that our final derivative is 3x squared. So it ends up working out if we say f of x equals 4x cubed, then the derivative is 12x squared. If we say f of x is 5x cubed, f prime x, what do you think it is? 15x squared. I'm running out of space here. 15x squared. Okay, cool. All right, that's it. Highly recommend you review the full lesson for this day because it was a lot. We definitely went through a lot of stuff, and also just continue to be patient with yourself as we work through our confusion and get more practice with these topics.